like introduce myself.
Yes. Okay. Very good. I'll start with that. Welcome back. It's Thursday, end of the week, and unfortunately, for the reason our SI I was trying to anyway, our assistant here. The reason he wasn't here is he still had the old classroom, which we had been moved here, so he was at the other place. Here we are. So anyway, I'm going to let him introduce himself.
Hi everyone, I'm your MAT210 SI, and I hope to see you guys in my session because I only held like the last two sessions. I saw no one, so I hope like I see more of you like coming to my session. Thank you.
And then just remember, let's see if I can get there. When you come into Canvas from my ASU, you always get these two choices. This is our class that we do. This is the SI help. So click on that. Oh, it's denied. Maybe I'm not a student, probably. So it won't let me in, but it should let you in. So, and then you can get the assistance that you need. All right. I know I can get into this one. Okay. Very good. So we're going to give you just an overview of where we're at. We're getting close to our first exam. Remember, we'll have 3 exams, and then the final, which will be comprehensive. So we just want to keep seeing you make progress. We did the special sort of the shortcut rules on Tuesday. We're going to continue with that and do an application. So there's no real new math that we're going to take a look at. We're just going to apply what does the derivative mean in a business setting. And again, those of you who are involved in marginal analysis from maybe your business classes, that's exactly what we're going to do today. So marginal cost. Then we get into a little bit more on the derivatives, so back to the math side of things, of some new techniques. We'll have a full review next Thursday. I'll have a new quiz posted. There was one that was popping up saying it was due, I don't know, the 25th or I moved it out. It was from last semester. I may use it, or some of those. They created some new questions and such for the quiz. Again, the way I'm doing the quizzes is they're going to be test review type quizzes, so then you'll be able to work through them multiple times. The goal is that if you put in the effort, you'll get them all right, and you'll get well prepared for the exam. Okay. And this Tuesday, so it's a week down the road, not next week, the week after, we'll actually take the exam in here. I haven't taught this class in about a year and a half, so when we were doing it before, you take the test through the WebAssign, but now they're having you take paper and pencil tests. I haven't seen them, but I should get a view of it before our review, so I will give you some more details about that. But it should be very similar to the questions we've been working on. Okay, any questions? Is it all working out for y'all? Making some progress? Okay, remember if you need an extension on anything, just send me an email, contact me.
Can you repeat again the exam block? So it should be here or it should be on?
It'll be here on paper pencil. So bring your calculators, paper. Yeah, you can use scratch paper, but it'll be provided. Yeah. And it'll be here on that date. So if you need any extensions on the homework, just let me know. You don't have to explain why you need it. Just say, I need it, and you'll get it. Okay. Excellent. So then where we're going to go today, and what I'm trying to do is kind of each lecture is a section, so I've got a different module for it. There'll be the slide deck, so anything you see up here, you'll be able to pull up yourselves. And then I record it. I'm doing the screen recording here as always, and so you can view that later, or if you miss a class or if you're not here, that's the way you do it. So this is our first application of a derivative, the marginal analysis. But before we start, what is a derivative?
Instantaneous rate of change.
Instantaneous rate of change. So that's sort of the big name, the long name for it, right? What's another thing we could call it? instantaneous rate of change. So we're at a point, that's how it's changing. Something to, yes? A tangent line, yes, so that it's the slope of the tangent line. Nothing, it's just the slope of the tangent line. So remember, slope is a rate of change. It's where we're going. It's not necessarily where we are, it's where we're going. And so when we think of a marginal analysis, the whole thing is we're at some point, we want to know what will it cost us, or what will our profit be if we get to the next point, the next piece of production. We're making cars. How much what will be my profit if I make one more car? Or what will be the cost if I do one more? So it's that idea of slope. We're taking one more step. What is it? We're going to use the slope of the tangent line. Now, as we saw, where does the tangent line touch the function? Draw a little picture here. Okay, so if I've got a function, there's our function, and I'm going to draw in a tangent line, say, here. Not real, actually, I'm going to get a little practice here. I didn't want to do that, okay. Graph. Actually found out they've got a line tool. So if I'm going to draw a slope here, so where does the tangent line touch it? It's touching it at the point of tangency, right? Where's the marginal? We're talking about the marginal analysis. Where is that? If this was, say, at 50, what are we looking for the marginal? We're looking at what would it take to get to 51. That's our next step. Notice, at least on this drawing, we're going to follow the tangent line. But is that the actual cost? It's not. And it might be close, depending upon how far, what the graph is. But it could also be off. But we're using marginal analysis to get an estimate of what that should cost us for that next one. And we're going to do a problem together, and we'll do it both ways. We'll calculate the costs using the marginal, and then we'll calculate it, say, here's the cost of the 50, here's the cost of 51, we'll subtract them. It might not match up exactly. Sometimes they do, they're pretty close, but sometimes they won't. But the marginal analysis gives us a tool to get an estimate. So that's when we're making our business decisions, we don't always need to know down to the penny or down to the dollar even, but we need to know a good figure, and that's what the marginal is going to get us. Okay? But I want you to see is when we're using our calculus, we're doing an estimate. We're always doing an estimate. We're going out into the future, and in this case, the function might be changing and going up and down, and so it might be a good estimate, it might not be. And that's where we have to check is if we get too comfortable with always working with our derivative, and it's taking us in, and again, sometimes it's going to be very accurate. We got to be careful. We want to check to see how things are going. Market drops off tomorrow and it's no longer accurate, right? What was, 2 o'clock yesterday, the stock market might have been going up, but at close today, it could be in a very different direction. So you gotta keep up with those things. And again, a lot of what we're doing tonight is not so much math, it's this analysis part, which is just some problem solving. So we're gonna look at just cost, revenue, and profit. 3 things that are all related, right? So the cost is what it costs us to produce as a factory, is whatever we're doing. It's what we have to pay to make something. What I find is, you guys are probably better at this than me, but what's the difference between revenue and profit?
Would revenue be like everything including cost, like what you're paying, and profit is everything minus like the net cost?
Yeah, so profit includes the revenue, having the cost subtracted off. So revenue, though, is just the money in. So it's what I sell it for, or, you know, the money that comes into the company. But it's real easy to confuse these two. But profit is revenue, but it's what the cost taken off. But revenue and profit are not the same. I can make a lot of revenue, but I could be losing money if my costs are higher, right? So just get that the revenue is just strictly cash coming in. Costs are what I have to pay to get it out, and then the profit's a combination of those two. And again, simple, but it's also very simple when reading a problem to confuse revenue and profit. I do it all the time. Not on purpose, but it happens. Okay, so again, this is going to be a little bit more wordy. There's really only a few examples that we'll go through, because as you'll see in the homework, here's a function, take its derivative, there's your that's the function of the marginal. The marginal and the derivative now are another word we can use. So we've got slope of the tangent line, we have instantaneous rate of change, and we have this word marginal function. They're all derivatives. So it's just kind of multiple words for exactly the same thing. Okay, so we've dealt with cost functions that are linear, right? The constant rate of change costs $5 to make these things, and the next one's going to cost $5. This next one's going to cost $5. That's a constant rate of change. It's a linear function. Okay, and so in this function, we've got the cost. X is the number of items, the number of little water jugs we're making. And M and B are constant, so M is the slope, the rate of change, really the cost of how much it costs to make each one. B would be what in the terms of a business problem? B doesn't have a variable. Startup cost, right? It's a fixed cost. So that's what you're going to see there. The variable costs have the X, because we have to pay more each time. So B's are going to be our fixed costs. So we'll get some hint. And then notice if this is a simple, if we're dealing with a linear cost function, the derivative is simply M, because it's mx plus b, right? Derivative here is 1 times m is m, 1 minus 1, x to the 0. So it's a constant. The cost has the marginal cost is constant. Easy to keep track of. We know exactly it's going to cost us $5 to make this one. It's going to cost $5 to make the 150th one. Okay. We're also going to look at some situations that are not that simple, and that's real life business, right? The more you make, oftentimes you get economies of scale. It becomes cheaper to make it down as you make more. Okay. So, but the linear cost function actually contained the derivative in there. So a lot of times we were doing this, we could do marginal business analysis with just a linear function without really ever thinking about calculus. We just say, oh, the slope, that's our rate of change, that's our marginal. With a linear, that's all we do. But when we get to things that are not linear, we need to understand, we're going to need that derivative. And the concept's the same, but the math behind it's, one level up. Okay. So marginal costs, we're going to start with that. So we get a cost function. So it's some sort of equation that tells us each time we produce X number of things, that's how much it's going to cost us, right? So we'll be dealing with them as a cost function, C of X. Notice there is no prime there. When we talk about the marginal cost function, we're going to have this little prime here. So it's, again, in math, and those are two very different things, aren't they? The first function, C of X, is the cost for producing that many items. So in our first example, we did, say, C of 50. And what did that represent? The cost to produce 50 items. Total cost to produce 50. I can't look up there. But what does C prime of 50 give us, represent? So you notice it's just a little different, a little prime. What is that going to give us? It's a cost.
Cost of producing a single item out of
Yes, so the cost, the additional cost, so yeah, we'll write that down. The additional cost to produce the 51st item. And remembering that is an estimate. It's not going to be necessarily exact because it's a different function, right? So this is the, what did I say? The cost for, the estimated cost. Estimated cost. Estimated additional cost. Let me, estimated additional. I'll just, to make 51, the 51st, actually, not to make, because if I plug in 51 to the original function, that'll tell me the total cost to produce 51 items. But when I use the marginal, it's an estimate of how much additional it'll cost me to produce one more, which, you know, so, oh, got the order wrong. I need 51. Let me go make one more. So that's what that's going to give us, okay? And so far the math is just going to be, we're going to take functions, take the derivatives. That should be fairly simple derivatives like we were working with on Tuesday. Okay. The units, again, cost is going to be in dollars. Maybe I should erase that. There we go. So, you know, cost is going to be in dollars or euros or wherever we're making them. But the marginal costs are always, remember, it's a rate. A rate is cost per item. Okay, so the marginal is cost per item. The original one is just cost for however many items we're producing. So this is the approximate cost for one more item. That's it. That's the whole lesson tonight, really. Nothing, there's nothing really more new. We will get some practice with taking our derivatives and stuff, but that's the concept. It's one more item. That it is an approximate or an estimated cost for the next item. And it could be a small item like a water bottle, it could be a whole, you know, a Tesla. Here's, you know, what it costs to make one more off the line. So here we go. Linear function, right? So we could actually, again, in algebra, we're thinking of this. What is this? What is the $1,000 here? Let's see, C of x, 400x, $1,000. Those of you in, I don't know, it's not supply chain, but yeah, fixed cost and variable cost, right? 1,000 is a fixed cost. So the setup cost, whatever. So whatever we're going to make, have to have a setup cost. How much does it cost us to make each one? That's the variable cost, right? Each one we make is going to cost us 400. So we could do this with algebra. We could say it's going to cost us $400 more to make the next one. Okay, that's also our marginal. So if we take a very simple look at this, we take the derivative, right? So this is x to the first power. The 1 comes down, 1 times 4. We're actually going to calculate this, would be 400. Subtract 1 from the exponent, we get x to the 0. Derivative of 1,000 is 0. So you'll see fixed costs don't factor into marginal analysis because fixed costs are a constant. You take its derivative, it's gone. That's the math behind it. Okay, so just like they say, C prime, in this case, is going to be always $400. Now, I'm going to show you when we have this this function, we can analyze it, say, okay, what is the cost for the first item? That's 400 times 1 plus 1,000. It's 1,400 to make one item. What would be the cost to make two items? 400 times 2 plus 1,000. That would be 1,800. But you notice, if I wanted the marginal of 1, again, what did we say the marginal would be? The additional cost to produce 1 more. So we can come here, well, it's going to be $400, right? Because that's the marginal, it's the derivative, it's 400. But we could also do it this way. So if it cost me 1,400, this is how much it cost me total to produce 2. How much additional was it? 400. Right? So that's what nice thing with linear. If we have a linear cost function, the math becomes very easy, and it becomes very accurate because we've got this constant rate of change. And not only is it an estimate, it's exact, right? We could do a subtraction here. Difference of 400. This is going to be 400. So I just want to show you that's the simple. What we're going to do now is up it a little bit. We'll use maybe like a x squared, and so then we're using we actually have to go to the derivative, and we're actually getting an estimate, not an exact value. But that's what we'll do with the marginals. So far, is it pretty clear? Any questions? Derivative is, what are all the things a derivative is? Slope of the tangent line, instantaneous rate of change, and tonight we learned it's also the marginal cost. So all this, 3 different words for the same frickin' thing, right? But that's how, we just have to see they're all connected. And the biggest confusion is you start seeing them as not really understanding or something, you see them as different things. But they all those are the same thing. Okay. So let's now take a look at a marginal cost that's not a linear function. We're going to look at big numbers. So we're stepping up in the world. We've got a much bigger factory. We're taking portable music players, and X is the number of music players manufactured. So notice, let's just kind of look at this function. Even though it's not linear, we could still pick out something. What does this 150 represent? Fixed costs. So that's what I want you to do, is if you can get in math and you see the patterns, you start seeing, you connect it with your business theory or business principles, that's your fixed costs. So I want to make some of these, I got to go get a factory, I got to get equipment, it's cost me $150 just to set up, right? What's this 20x? It's a variable cost. Well, it's part of the variable cost, right? Because there's another part that still also has a variable in it. So it's, I guess I should say, there's this part too. So there is part of the variable cost. So, but what would you say that $20 sort of represents? It could cut each unit. But what's also happening as we produce more units, we're subtracting off, we're getting some production scale. Maybe we're able to buy things cheaper because when we buy a lot. So there is, it's getting a little bit cheaper to produce them the more we produce. So it is, all of that's part of the variable cost is it's no longer linear, it's no longer fixed, because the more we produce, we'll save a little bit on that next one. So we can kind of see how that's going to happen. So anything with a variable, right, this all is your variable cost. But you can kind of see, okay, it costs about $20, but I can save some the more I go down. And since we're jumping up to 50,000, this is not even a penny, right? That's 0.0000. It's a hundredth of a penny that you save each time you make it. But maybe at 50,000, that might make a difference, right? It's going to do something. So we could see. So the thought is, if I produce one, right? I've got this big cost here. It's going to cost about 150. In fact, let's go ahead and do that. So the cost of one would be about 150,000. That's that plus 20. 20 times 1 is still 20. I'm going to leave this off because it will be so small that it rounds off. It's not even a penny. So we could say that really to produce the first one is 150,000. And 20, 150,020. Okay. Cost to produce 2. Again, if you plug in 2 for all the x's, you'll still see you got this 150, but it's going to be plus 40 2 times 20 is 40. And this again is so small we don't really care about it. It's going to be close to $150,040. So we can kind of see there's, at the low end, it's the marginal cost is about $20. It costs us 20 to produce them. That's probably the materials and everything, okay, labor. But how are we going to find this? We don't want to keep going this way, right? Because then we have to subtract it. So we want to jump out there. What do we need to get the marginal? We need our derivative, right? We need the derivative of our cost function. So let's do that. Derivative of the cost function. Derivative of 150,000, 0. I like this math. You got a big number, you take its derivative, it's 0. Nothing to do. Derivative of 20x. 20. So the 1 comes down, subtract 1 from the exponent, x to the 0, which is 1, right? So this is just going to be 20. How about this last part here? We've got a negative. The 2 comes down. So what's 2 times that? Well, 0.0003 zeros and a 2. 2 times 1 is 2. And then it's x to the first power. So we see that's got something. So we'll just clean this up a little bit. So the derivative of x, don't need that 0. We don't need 20x to the 0. We'll just do 20. Okay. So now what do we do to figure out what's the marginal cost to manufacture, or what's, find the marginal cost function and use it to estimate the cost of manufacturing the 50,000th and 1. All right, so we've already made 50,000 and they said, oh, go make another one. So how do we do that? We use the derivative, but what number do we use? What's our input? 50,000, not 50,001. We're looking at the derivative of 50,000 because then that's going to tell us, that tells us what it will be shooting for. So that's kind of the first thing that I mess. I'll just put 50,000. Now it'll probably be close enough, but it won't be correct. So we plug in 50,000. So that's going to be 20 minus 0.0002 times 50,000. You might think, oh, got to get the calculator out, but with these zeros, it's 1, 2, 3, 4. So I can move it back 1, 2, 3, 4. I'll give a 5, and then 2 times 5 is 10. 20 minus 10. So our marginal cost for the 50,000th and 1, and again, that's the derivative at 50,000, is going to be $10. 20 minus 10, $10. So you see it made a difference. It's not costing us $20, and it's costing us 10 for each one. Now those first 50,000, especially the first one, still cost us $150,000 and $20. But yeah, it's going down, and so the more we produce, and that's why, that's why things like computers, that used to, little thing like this would have, my dad got into it, he was during the 60s, and he remembered, he says, the first computer they used in their, he was doing the work for Consolidated Freightways, he says it took like the whole floor was their computer, and had about the and your graphing calculators have more calculating power than that. They're very expensive, and then by the end of his career, we got laptops that can do more than a whole building worth of old computers did. So it's just, as we make more and more, we get better and better, and we reduce the cost. Okay. Now, you could also go in here to the original function, plug in 50,000, and then do a second calculation, plug in 50,001, and then subtract the 2, and you'd see it would probably be close. It might not be exactly $10. It might be $9.99, or but you'd be pretty close. Okay. But this is the way that we do marginal analysis, because we're dealing with big numbers, it's gonna be close enough. And I'll bet you, but take the derivative, look at the one that we're producing, so we're looking at 51st, do the one before that, and the marginal gives us the next one. That good so far? Okay. Marginal revenue and profit. And again, profit is just, sometimes they give us both, those as functions, but remember, profit is revenue with the cost subtracted off. So get that interrelationship. So they'll give us, function R, function P. Those are actually going to give us the values. How much revenue are we going to have coming in? How much profit do we end up making after everything? And then we're going to do what's called marginal by looking at the derivatives of those functions. And again, we'll have a revenue, derivative of the revenue, derivative of the profit. So how much more do we make by selling that extra ticket? And typically, the more you sell, actually your profit's going to be more because you've already absorbed the costs in the early tickets, right? That's the idea of the marginals. And remember that the marginals are measuring a rate of change. So they're telling us how much for the next one. They don't tell us the profit, they don't tell us the revenue, they tell us how much more we get if we go one step more. And again, sometimes you could use this and say, well, what if I did 10 more? But remember, when we're using the marginal, what are we using? The tangent line. The graph might be going, so the more we use it for, the more error we could probably have. So that's why we're sticking with marginals, we try to keep it one more item. It's pretty accurate for that. Units, again, when we talk about marginal, it's always per item, per unit. So it's not just dollars. Dollars, profit is going to be in dollars or euros or whatever. Revenue will be in monetary units, but the marginals are always monetary units per item. It's a slope. And that's one of the things you'll see throughout this class is you'll be given a function. It's items, it's dollars, it's this, it's that. The derivative is always this per that, right? So speed or whatever we got, but there's always it's a rate. So it's approximate revenue that we get from one more item. So it's good. Once we get this down, that's all there is to it. So in this one, I went to the book because I was looking through the homework, and I figured if I just did the homework up here, then you might not get it. So I'm doing a similar problem that was in the homework, but I take it out of the textbook because the work's the same. So they give us, we're going to look at the same graph, and they're going to ask us 3 questions. So the first one, the associated marginal cost is doing what? So this is a cost function, right? It's C, it's not C prime. I guess we'll write in here cost. These are items, these are dollars. What's happening to the marginal cost? We can see the cost. Remember, this function is showing us what's happening to the cost. The cost is increasing, but what's happening to the marginal? So down. Good. So yeah, so we could come like down here. I'm going to try to draw some tangent lines, but we'll see how this works. Yeah. So there's that tangent line. About here, let's see if I can draw that very good. This tangent line, if I can get it up. Well, we'll say that's connected, but yeah, you could see it, and that's what I tried to do. You get where you can kind of visual. The tangent lines are also increasing in slope. They're getting bigger, so, and they just keep getting bigger, right? Increasing, then no, decreasing, then they're always increasing. Okay, so looking at that graph. So we were doing this a little earlier on some other graphs, and what's happening to the derivative. So when we talk about a marginal, we're just talking about the derivative. It's the same connection. So just kind of see the slopes. What are they doing? Now, remember when if it was going the other way, the slopes are becoming more negative, right? But this is one of the, I've talked with a few of you. The rate of change is actually, it's decreasing faster, right? As we go down this way, but it's decreasing, okay? So the cost would be, as it gets more negative, the way they talk about that it's decreasing. Okay, now, when x is equal to 100, the marginal cost, so how do we do that one? Come to 100, what do we need at 100 to get the marginal cost? Instantaneous rate of change, which we can visually see from the tangent line, right? So again, I'll see if I can draw a better tangent line here at 100. I know I can go this sort of this way. Go. Kind of good. So that's what the instantaneous rate of change is about at 100. It's a slope, right? Greater than the average cost, less than that. How do we get the average cost? Well, they didn't give us an interval, but remember, we'll assume they went from the beginning to the end. The average cost is a secant line, not the tangent line. So we're going to connect the 2 points from the starting to the ending. What do you think about those two slopes? About equal? Yeah. My drawing's not perfect. They're not probably perfectly parallel, but they're close enough. They look pretty parallel. If it's going to be something else, one's greater than the other, you could see that. Yeah, if I was at maybe 150, it would be 150 is going to be greater than. But at 100, it's about the same as the average cost. Okay, so again, that's what we're kind of doing is we're trying to eyeball approximately equal. Whoops. Kind of trying to eyeball tangent lines because that's the visual representative of a derivative of a marginal. Okay. And again, the marginal would just be the 101st one, which will be here. We can see it's kind of close to the graph anyway, so but that's what we do. And this next question is going to throw you, what is the cost of 150 items? Do we need the derivative for that? No, that is a value. It's not a rate. What is the cost for 150 items? So they're switching back more to the algebra mode. So we come to 150. It's right there. But, okay, that's all we need. But notice they've got two. Yeah, that's about 4,000. This is 5,000, so it's almost, 4,400 looks about right. But notice they've got two of them. And a couple of you have asked me about this. How do I know whether it's whether the rate is increasing at $1 per item or $40 per item? What is that talking about, the rate of increase? What do we need for the rate to figure out the rate of increase? What kind of line? Not a secant, tangent line. Rate of change, tangent line. So the way we can estimate it, and again, maybe we'll just, a lot of times we just guess because, but what we would want to do is draw a tangent line from here. I think it should kind of go, let's see if I can get it. That sort of looks like I guess. And so again, we're going to estimate, is that about a $1 per chain, $1 per item, or is that $40 per item? Well, we got to try to estimate the slope. We're at 150 here. This would be, the 150 was 44. Let's see if we can quantify this a little bit. And again, we can only do so much. So 150, we figure at 4,400. And then what can I do? Maybe this one at 125. It looks like if this is accurate here, that looks like 3,000. So now I've got a way to estimate the slope, right? I could say y2 minus y1. And again, I'm using a secant line, well, actually, I'm using the tangent line, but I'm using 2 points on it to try to estimate this. Because I look at that, I couldn't tell if it's 1 or 40. You would think you could, but, and then 150 minus 125. So we're just using the slope of the tangent line, estimating like we did earlier on. This is what? This is 1,400. And this is 25. Well, it's more than 1, so it's got to be the 10. Now, our 1,400 divided by 25 probably is not exactly 40, but again, we've got two choices. It's either $1 or it's 40. I'm going to go with A. Does that make sense? Okay. So we don't have to get exact values on these, but we have to tell the difference between 1 and 40. And actually, when I was looking at it, I said, I figure it's 1, because that seemed the easiest. But pick 2 lines off, sort of estimate a tangent line, pick off 2 points, then you can get its slope. This is all calculus. And the cool part of it, that's really all calculus is. The hard part is all the algebra that gets you up to it. But we're cutting out some of that algebra part as we go. Okay, so one last one to look at, one last example. And then again, if you'd like to stay after we finish, so the lectures, I don't try to keep you here right up to the end, because I'd like to have some time for questions, and if you want to work on things, that's great too. But here we got another marginal cost, and it's kind of like the same type of deal. We want to find the 60,000th, the first cost of it. So, and again, I just took this one out of the homework this time. So what do we need to do? Get the derivative, exactly. Because whenever we want a marginal, first thing we're gonna need that derivative. So the derivative, do that. Like this part, anytime there's a constant, its derivative is 0. I'm gonna write it down just so that you see I didn't forget about it. It is, yes?
Even if that number is not that big, the first one is still always 0.
Yeah, if
Okay.
it was 2 or 3.
So-
Yeah, that's cool, yeah. If it's negative, it's still 0. It's always, any constant, its derivative 0. Because remember, what we're getting when we take a derivative is the slope of a tangent line. And if it's a constant, it's a horizontal line. That slope is always 0. Good. Always good to make those connections. And then we move forward, and then you forget about it, and you have to go back and remind so it's a stage of continual reminding. And even when I teach these, I did it last semester, but I teach it this time. Oh yeah, I forgot about that part. So it keeps making sense. So 340x, what's that derivative? Just 340, because the 1 comes down, we get 340. Subtract 1, right? X to the 0. I'm going to go ahead for, just as we're still here, just to remind you, it just doesn't disappear, but it does, right? X to the 0 is 1, so that's going to go away. And then this last one, we've got the 2 that comes down. So that's going to be plus 0.00. 2 times 5 is 10. So that's 1, 0 if you want. And then x to the 1 power. Okay, we'll clean it up a little bit. The derivative is simply 340 plus 0.0010x. Now what's happening in this case? Are we getting economy of, the more we produce, is it getting cheaper? No. For some reason, maybe we have to go mine some more rare earths or something, and it costs us more. So this is not the more we make, the cheaper it gets. There's actually a slight increase to the costs. And so if we want to find the cost of 60,000, or the marginal for 60,000, or estimate the cost of the 60,001, how much for that additional one, again, we put in 60,000, the derivative at 60,000. So 340 plus 0.00, I'm going to drop off that last 0, and then we've got 60,000 here. And again, don't so that when we multiply by powers of 10, it's 1, 2, 3 places we need to move the decimal. So I'll move this decimal 1, 2, 3. So that's going to be $60 extra for that one. So it's going to be 340 plus 60, so $400 for one more. So again, early on it was only costing us $340 for each one, but as we get further out here, it's now costing us $400 for each additional one we want to make. One more zero. Now it also says to compare this with the exact cost of producing that one. And again, what do we need to get that? We need to go back to the original function. We would need to find C of 60,000, and then we would subtract, or maybe we would do it the other way because it would probably be higher in this case, 60,001, and then we would subtract these. So you figure out those two values. And again, what you'll find is that it should probably be close to 400. I'll let you do it if you want to, but that's the difference. So we can actually, and sometimes in business, your analysis, you want to do both just to see how accurate you're getting. You say, okay, at this, we're still pretty accurate, we'll do it. But remember, sometimes we get out a ways, that marginal is less and less accurate depending upon how things are changing on us. My estimate would, since we're still out here, this is not even, this isn't to a cent even, so we're probably still going to be pretty accurate. But again, it could be just something, if this was, say, 10x or something, it might not be as accurate. So we do those analysis. So being able to have those tools, that tool set. But a marginal, so let's sum up, because I think we're done. Yeah, it doesn't let me go to the next slide, that means there are no more. So the lectures are done. A marginal is 3 different things. Well, we talked about 3 different names for the same thing. One is a marginal. What's the other thing we could call it? Slope of a tangent. So always remember, because a tangent line also has a y-intercept, so sometimes we need that, but it's the slope of the tangent line. That's a specific part. Good. And we also call that the instantaneous rate of change. That's cool. We could never talk about that with algebra. Algebra only gives us average rates of change. Calculus gives us instantaneous rate of change, slopes of the tangent line, marginal cost, marginal revenue, marginal profit. And in the homework you'll see though, it's pretty much the same process whether you're talking profit, revenue, cost, but the mathematics of it's all the same. They'll give you a function, get its derivative, that will give you the marginal whatever you're doing. I think they have a couple where they have you combine things, but I'll let you work through those. And again, practice taking the derivative, getting marginals, and thinking about what's the cost of that next item. Awesome.